Let us evaluate the integral of secant to the power 10 of x. When dealing with an integral of secant and your exponent is an even number, you would first need to factor out a secant squared of x, making this secant to the power 8 of x multiplied by the factored out secant squared of x of dx. And for the remaining terms here, you would want to transform this into its trigonometric identity, wherein secant squared of x would be equal to tan squared of x plus 1. Since what we have here is a secant squared of x, put this in a secant squared of x form, which would be secant squared of x. 8 divided by 2 would be 4, multiplied by secant squared of x dx. Now that we have that, we can now transform it. Now, there are two ways now in which you can proceed further. You can either expand this now as it is, or use u substitution on tan first in order to get rid of secant squared of x. But in my case, I would first want to just expand this as it is. We have here a power of 4 of expansion. The formula for this would be a plus b to the power of 4 would be 1a to the power of 4 plus 4a cubed multiplied by b plus 6a squared multiplied by b squared plus 4ab cubed plus b to the power of 4, wherein a here would be representing tangent squared of x and b here would be 1, which makes this the integral of 1a to the power of 4, which would be tan squared of x to the power of 4, which makes this tan to the power 8 of x, plus 4a cubed would be tan squared of x to the power of 3, which would be tan to the power of 6 of x. And remember, the b here is simply 1, plus 6a squared, which would be tan squared of x raised to the power of 2, which would be tan to the power 4 of x, plus 4a here now would be simply tan squared of x, plus b to the power of 4. b here is 1. 1 to the power of 4 is simply 1. And copy the rest, which would be secant squared of x dx. Let me just put this in here. And now for the next step, let us use u substitution, wherein u here would be equal to tan. The derivative of tangent of x would be equal to secant squared of x dx. And isolating the x, we would have the value of du over secant squared of x. Now that we have that, we can now substitute all values, which makes this the integral of tan to the power of 8 of x would be u to the power of 8 plus 4, which makes this u to the power of 6 plus 6 u to the power of 4, and so on. And for secant squared of x dx, I just realized something. It is directly related to this. Secant squared of x dx, which is this, is du. So we can simply put this now as du. But if we want to follow this format, copy first the secant squared of x, and the dx here would have the value of du over secant squared of x. And you can see here that the secant squared of x would cancel each other out, which leaves you with a du. Now that we have all of this, we can now integrate this one by one, starting with this first. The integral of u to the power of 8 would be u to the power of 9 over 9 plus 4 multiplied by the integral of this, which would be u to the power of 7 over 7 plus 6 multiplied by integral of this one, which would be u to the power of 5 over 5, and so on. And the integral of 1 du would be equal to u plus c. Simplify all the coefficients first. We can rewrite this as 1 over 9 u to the power of 9 plus, for this one would be 4 over 7 u to the power of 7 Now for your final answer, just put all u values back into tan of x. And thus, for your final answer, which would be equal to 1 over 9 tan to the power 9 of x plus 4 over 7 tan to the power of 7 of x plus 6 over 5 tan to the power of 5 of x. Plus c.